Okay, hello and welcome to the video. This is the second one on ellipses, and this time we're actually going to be writing the equations versus given the equation. Now I want to do a quick review on the formula for the equation of a circle. Remember, it is x minus h squared over a squared plus y minus k squared over b squared equals 1. And remember that your the major axis, in this case is going to be 2 times a, and your minor, your minor axis will be 2 times b. And remember, whichever one has the x as far as the larger number will determine whether or not you have a vertical or horizontal ellipse. On the ones that I'm giving you, we're just going to go with the fact that we have a horizontal ellipse. So that's what we're going to go with. We're just going to write an equation here. So this one goes through the origin. That means there is the HK is 0, 0, so I really don't need to add or subtract. So I'm going to go ahead and write that piece in. It's equal to 1. Now again, my major axis is 2 times a, so that is going to make a be 4 in this case. But then underneath my x is my a squared, so this is going to be 16. And then my b is 4. And that means that b is 2, because 2 times 2 is 4. And my b squared would also be 4. And then I'm done. Okay, so don't make it overly difficult here. So when I go to do my next one, the center is at 2, 3. So I'm going to first go ahead and get my center in. Now again, remember a is going to be, or your major axis, I should say, is 2 times a. And so a in this case is 5, and then 5 squared is 25. And then we have 2 times b is 6. That's going to make b be 3, and b squared is 9. Okay, very easy to write your equations. Okay. The next one's a little bit different because I'm going to give you the vertices and the co-vertices. So if I tell you that your vertices go from a -3, 2 to 5, 2, okay, and if you need to, you could sketch that out. -3, 2, we'll say, so -3, 2, and 5, 2, 1, 2, 3, 4, 5, okay. Then my major axis here is going to be a length of 8. And so 2a in this case is 8, so a is going to be 4. And my co-vertices are at 1, 4, so 1, 2, 3, 4. And again, you might not need to draw this. You can just do your distance formula. So 1, 4, and 1, 0, which is going to be a length of 4. So 2b is 4, therefore b is 2. And again, you could just look up here and see, well, my 2 stay the same, so from a -3 to 5 is 8. My 1 stay the same, so from 4 to 0 is 4. So that would work also. What I didn't state in this problem, though, was what my center was at. And so if you look at the graph, your center is going to be the midpoint of both of these, in the x and the y position. So your center in this case is going to be at 1, 2, because that would be halfway between -3 and 5 would be 1, and halfway between 0 and 4 would be 2. So 1, 2 would be my center. Okay, so with that information given, I can now write my circle. So x minus 1 squared over a, which would be 16, plus y minus 2 squared over 4 equals 1. Okay, so again, pretty easy on writing the equation. Now, just like with the ellipse, or just like with circles, it is possible that it is not in the standard form that we're going to need to run a completing the square. So same as before, we're going to complete the square. The first thing that I would do is to reorganize so that you have your x's together, and then again the y's together. And so my y's would be 4y squared minus, let me just go ahead and write this way first, then I'll go ahead and put in the step, plus 4y squared minus 8y. And again, I'm going to go ahead and move that 13 over to the other side, make it a negative 13. So my next step is to do a completing of the square. So in this case, half of 10 is 5, 5 squared is 25. So I'm going to add 25. Now on the second one, remember we're going to need to first factor out that 4, which is going to make this y squared minus 2y, which means half of 2 is 1 and 1 squared is 1. Now remember though, we do have this, so we're going to add 4 to both sides. When I rewrite this, I get x plus 5 squared, and then I have 4 y minus 1 squared equals, and when I add these up, let's see, negative 9, 16, okay? Now remember, the rule is when we have an ellipse is that this number is equal to 1. So all I'm going to do is divide everything by the 16. And when I do that, I have the x plus 5 squared over 16 plus, and in this case this is going to simplify, y minus 1 squared over 4 equals 1. And now there is my equation. Okay, so the part that you have to be very careful with, again, is this piece right here. And we've talked about this before when we completed the square, talked about that that's not my favorite way of doing it when we're doing quadratics. But when you're doing ellipses, it is, and circles, it is definitely the easier way to do it. So again, it just kind of has to depend upon which way you're doing it. Okay, so let's try another one. So again, first we're going to rearrange. And I'm going to go ahead and move the 39 over. There's my first step. My next step is I'm going to work with just the x's and then just the y's. So this time my x has a coefficient of 4, so I'm going to pull it out. And then half of 4 is 2, 2 squared is 4. But again, remember, this is actually 16 that I added to both sides. Okay? And then we're going to do our y's. So half of 6 is 3, 3 squared is 9. Add 9 to both sides. Okay? So this is 4, x plus 2 squared plus y minus 3 squared equals, and we're going to add all that up, and what does that make? 25 and 39. Can't do math in my head. So 25 and 39, I get 64. Very good. Okay, and then our last step then is to divide everything by the 64. So I get x plus 2 squared over 16 plus y minus 3 squared over 64 equals 1. Okay. So if you want to try the next one, if you want to pause the video and then you can do that and then watch me do it, or you can just watch me do it if you need another one. So either way. So the next one is, again, let's rearrange. And again, now I'm going to complete both squares. Now in this case, both of these has a number in the front, a coefficient on your x squared and your y squared. So I'm going to factor the 9 out. Okay, and then remember half of 4 is 2, 2 squared is 4. But again, I just do this so you see it, that is actually 36 that I've added. Okay, I'm going to do the same thing to the next one. I'm going to take out a 25, and that now makes that 2, which half of 2 is 1, 1 squared is 1. And that makes this be a 25 that I added to both sides. So I get 9x minus 2 squared plus 25, y plus 1 squared equals, and let's add this all up on there, 164, 36 and 25 is 225. And not all the time, but most of the time they'll try to make those where they are perfect squares. So if you end up with this side over here not a perfect square, you just might double check, because like on the test or something, because I'll always give it to you as a perfect square just to make it easy on you. Okay, next step is to divide this off. Okay. And that means that this will be x minus 2 squared, and 9 over 25, 225 is 25, plus, and then here and here, so 225 divided by 25 is 9. And you've got your equation. So that's probably about the hardest that you would find, in which both of them have an a value that you would need to factor out. Okay, so that is your equations for ellipses.